So now that we've taken a look at the reverse power rule, it's about time to actually go ahead and extend the reverse power rule to negative and fractional exponents. And so as a little bit of a review, the reverse power rule tells us that if we're taking the indefinite integral of x to the n dx, then that's just going to be given by x to the n plus 1 over n plus 1, and then we can't forget the constant of integration. And this is going to hold true for every n is a member of R, except that n can be equal to -1. And even if you do look at the formula over here, if you input n equals -1, you will end up with 0 in the denominator, and then that becomes a whole mess. So for the time being, we're going to actually go ahead and ignore the case where n equals -1. But if you do put in any other real number, whether it be a rational number, an irrational number, a negative number, an integer, it doesn't really matter. As long as it's not equal to -1, then this formula will hold true. And so what we're going to do is we're going to go ahead and see how we can use this formula to determine the integral of negative and fractional exponents, right? And so let's go ahead and actually do that. So over here we have the indefinite integral of the square root of x dx. And so what we can do first of all is we can go ahead and rewrite this as x to the 1/2, right? We're not really changing the value over here. We're just re-expressing the square root of x as x to the 1/2. And so now what we can do is we recognize this as kind of this form of x to the n, in this case, n equals 1/2. And so all we have to do right now is just increment the exponent, so x to the 1/2 plus 1, and then we just have to divide by that new incremented exponent. So divide that by 1/2 plus 1, and then we can't forget the plus c. And then we can just go ahead and simplify everything. So we can use a common denominator to obtain x to the 3/2, and then we have to divide by that x to the 3/2 as well. That's going to be a plus c. And we can go ahead again and rewrite this as 2 over 3. And then if we want, we can rewrite this x to the 3/2 as the square root of x cubed, and then plus c, and that would be your final answer. Although any of these forms are acceptable. It's whichever one you prefer, whichever one is a little bit clearer to you. And I encourage you to go ahead and take the derivative of this function, and you will come to find that this is in fact equal to the square root of x. So it all does work out quite nicely. And then next up here we have a definite integral. We have the definite integral from 1 to 2 of 4 over x squared dx. And so first of all, again, we can go ahead and rewrite this as the definite integral from 1 to 2 of 4x to the -2 dx, right? Because when we bring the x squared out of the denominator, when we bring it up to the numerator from the denominator, then we just have to switch the sign. So we're going to end up with 4x to the -2. And in this case, now we have n equals -2, and we just have to apply the reverse power rule formula. So we're going to get 4x to the -2 plus 1 over -2 plus 1 plus c, right? And then what we can do is just simplify this all out, and we end up with, or actually, we don't even need the plus c. I just realized it's definite integral. So we're going to evaluate this from 2 to 1. And then what we can do is we can just go ahead and simplify everything. So we get 4x to the -1 over -1. Again, we're evaluating this from 2, or at 2 and 1. And then we can simplify this even more. We'll end up with -4 over x. And we're going to evaluate that from x equals 2 to x equals 1. And keep in mind, I mean, if you would like to, you can go ahead and differentiate this, and you'll see that this does actually work. We do end up with 4 over x squared. And when we're taking a definite integral, we don't really need to add the plus c. And so then we can just go ahead and substitute x equals 2, so we end up with -4 over 2 minus -4 over 1. That becomes -2 plus 4, which is just equal to +2. And so that would be our final answer right over there. And then finally, we're going to go ahead and do a an indefinite integral that combines everything we've learned in the past two videos. So we have the indefinite integral of 1 over the cubed root of x minus 1/2 x dx. And so let's go ahead and actually do that. So we're going to rewrite this. We can rewrite this 1 over the cubed root of x as x to the -1/3. This integral sign is really ugly, so I'm going to try to fix that. Okay, not much better, but that's fine. And so x to the -1/3 is exactly just 1 over the cubed root of x. And then we can keep this -1/2 x the same. Doesn't really matter, right? And so this is an indefinite integral. And so what we're going to do is we're just going to increment the exponent for the x to the -1/3. We just increment it by 1, and then we divide by that new incremented exponent. And then same thing with the -1/2 x. This is just an x to the 1, right? And so we get x to the 1 plus 1 over 1 plus 1 over 1 plus 1, not 1 plus 2. And then we have to include the plus c. And then we just have to simplify everything. So x to the -1/3 plus 1 is just going to be 2/3. And then we are dividing by that 2/3. And then this is just going to be negative 1. Here we have x squared, right? And then here we have a 2 in the denominator and a 2 in the denominator, so we get negative 1/4 x squared plus c. Simplify this term even more if we would like. We get 3 over 2 times the cube root of x squared minus 1 over 4 x squared plus c. And so that right over there would be our final answer. I encourage you to differentiate this to see or to validate that this actually works.